Okay, so sorry, but my battery died in the middle of the last video, so I'm just going to pick up where I left off. Um, we were talking about this function on this interval, trying to find the absolute extrema, and I said that step one was to find the critical numbers, and we found those, and that step two was to test all the critical numbers and the endpoints. So what I have down here is I've written down and I put them in order. So there's both endpoints. There's the endpoints of the intervals, -5 and 3. So -5 is going to be my first one, and 3 is going to be my last one. And then I also put my critical numbers in there. So there's -4 and there's 2. So I put all critical points and all endpoints, and I put them in order. You don't really have to put them in order, but somehow I like to. And what do I mean by testing them? I just mean plugging them into F. Oh boy, so that means I'm never quite prepared for this during the video, but I'm going to have to plug in some numbers. So, and I just realized some of these numbers are going to be kind of big. Like I'm going to have to put in -5 here, which the first thing I'm going to have to do is -5 cubed, which is -125, but I'm going to have to add and subtract that to other numbers. So let me just make sure I don't make a mistake. So I'm putting in the function. Squared minus 24x. Okay, so tell me, what is f of -5? F of -5 is telling me is 70. F of -4, it's telling me is 80. F of 2, telling me is -28, and f of 3, oops, oh, come on, f of 3 is -18, there we go. And then it's simple from here. The absolute max is just the biggest number that I see, and the absolute min is the smallest number that I see. So here's how I'll state my answer. Absolute max of 80 occurs at x equals -4. Right? I put the 80 here. I call that the absolute max, and the x value is where it occurs. That's the language that I use. And then similarly, the absolute min of -28, because that's the smallest number I see, occurs at x equals 2. And those are the absolute extrema. Let's do another example like that. It's just the same instructions, but it's a different function and a different interval. So step one is to find the critical numbers. That involves taking the derivative, f prime of x. Okay, so product rule here, I'm going to have -2x to the -3 natural log x plus, so that was me taking the derivative of x to the -2 when I left natural log alone. So for my next part, I will leave x to the -2 alone, and I'll do the derivative of ln x. Okay, let me actually, I'm not usually too big on simplifying things, but I'm going to have to work with this, so let me simplify it. I'd like to combine these. 1 over x, that's like x to the -1. So if I'm multiplying these, that's like x to the -3. Okay, so what are the critical points? The critical points are where this equals 0 or where it's undefined. So I'll have to remember to do that later, but first let me take care of when it's 0. So I have this. I see my common factor of x to the -3. Maybe the smartest thing for me to do is just multiply everything by x cubed. X to the -3 times x cubed would just be 1. So it's like I'm multiplying everything by x cubed. So I'm going to get -2 ln x plus 1 equals 0. So let's try to solve this. Maybe I'll move this over. So 1 equals 2 ln x. 1/2 equals ln x. And then when we solve this, of course, the way to get rid of natural log is to do e to both sides. So e to this power and e to this power. So e to the 1/2 is x. Let's not forget is f prime of x ever undefined? And remember last time I said, this is something that it's easy to forget to check. It is important. It does matter sometimes. In fact, the answer to this question for us right now is actually yes. If I look at the formula for f of x, there's a couple of things that could cause problems. First of all, remember you always have to be careful about division, and in fact you have to worry about division by 0. I don't see any division here, but actually if I think about it, there's division in disguise. A negative power is division in disguise, right? X to the -3, that's the same as 1 over x cubed. If you try to do 0 to a negative power, that's undefined. Zero to a negative power is like dividing by 0. It is dividing by 0. So you can't do 0 to a negative power. So this would be undefined at x equals 0. You also have to worry about the domain of natural logarithm. Natural logarithm can only take positive values. So actually this would be undefined if x is 0 or negative. Well, we already knew it was undefined if it was 0. So it's also undefined if x is less than 0. However, these values of x, where we just found that the derivative is undefined, they're not in the interval. So that's, for that reason, for this problem, we're not going to have to worry about those anymore. You only worry about critical numbers that are in your interval. So, okay, once again, there's two types of critical numbers. There's the ones where the derivative is 0 and the ones where the derivative is undefined. We just talked about the second possibility. We decided that even though it is undefined some places, it's not in the interval that we're dealing with. So essentially for us, the answer is no here, at least as far as we have to worry about. We did find one where the derivative was 0. And actually, let's go ahead and check, because the answer that we got is e to the 1/2. We should actually check that that's in the interval as well. So I am Now, this can be a little bit risky. I'm using a calculator. In the end, I want all of my answers to be exact. E to the 1/2 is not exactly 1.648. E to the 1/2 is some number that goes on forever and it never repeats like pi. So it's not exactly this, but it helps to use a calculator or a computer to approximate things. All I'm doing right now is I'm making sure that this is in the interval. If this is approximately 1.6 whatever, then yes, it is in the interval. This includes all numbers from 0.5 all the way up to 4. So 1.6 whatever would definitely be within this interval. So I'm just demonstrating to you that this critical number is something that we have to worry about. In other words, it is in the interval. So, in other words, that is in our interval. So, what do we have to do for step 2 is to do our testing. Of the endpoints, so my endpoints are 1/2 and 4. Those are going to be my first and my last. And in the middle, I'm going to put any critical numbers. So like that. Okay, and then how do we do this? Well, I'm plugging it into this, x to the -2 times ln x. Like this. Let me try to simplify this. What does a -1/2 power or -2 power do? First it does the reciprocal and then squares it. So if I do the reciprocal, that's 2. If I square it, that's 4. What can I do with natural log of 1/2? I can use log rules to write it that way. Natural log of 1 is just 0, so I can write -4 ln 2. So I'll consider that simplified. What is this one? E to the 1/2 to the -2, natural log e to the 1/2 would be, if I have a power to a power, I can multiply them, so that's like e to the -1. If I have natural log of a power, I can bring the power down. The natural log of e is 1. E to the -1 is 1 over e. So I get 1 over 2e here. F of 4 is 4 to the -2, natural log 4. So that's 1/16 natural log 4. And now the question is, which one of these is the biggest and which one is the smallest? Because whichever one's the biggest is the absolute max, and whichever one's the smallest is the absolute min. But by looking at these, it's hard for me to tell. You know, so this is another spot where I'm going to use the computer. So if I do -4 natural log 2, that's approximately -2.77. If I do (1 over 2 times e), I find that that's approximately 0.18. And if I do 1/16 natural log 4, I get about 0.08. And again, this, in the end, I'm going to put exact answers. I'm only using these decimals to tell me which is the biggest number and which is the smallest number. So it looks like this one's the biggest, and this negative one is the smallest. So let me just write my answer down here. We have an absolute max of, and now I'm going to put my exact answer. My exact answer is, it was this one, so, but it's 1 over 2e. 1 over 2e is the exact answer. The approximate answer is 0.18. So I put the exact one. And that occurs at the exact value x equals e to the 1/2. Meanwhile, the absolute min of, okay, it was this one, but I'm going to put the exact value, negative 4 ln 2, occurs at x equals 1/2. So that's how I put my answer.